Okay, so we use these things in chemistry called significant figures. And you'll use them also in physics next year, because we do a lot of measuring and we do a lot of calculating with our measuring. But why do we use these significant figure numbers? They seem kind of silly. This is why, because we're in science, we measure things. So, here we're looking at 3 different measuring tools. Okay, all we'll consider them rulers. We have our insect here measuring the length. And if you look at the different calibration here, we're going to have different ability to be precise and accurate in our measurement based off of the tool that we're using. So, you measure by estimating one place value past the markings of the measuring tool. So on measuring tool A over here, so if we're looking at measuring tool A, we have 0 as a tick mark and we have 1 as a tick mark. That's all we have. So basically, we have to estimate right here. That's all you get to do, right? So let's take a look. What would you, the more markings, the better precision you're going to get in your measurement. So for ruler A here, what would you estimate that to be? Well, 1's all the way up here, can't be 1, right?
But you can also say 6.
No, but I can say it's something in between. Is it more than half? Okay, so it's above the half mark. So what are we talking here? 0.6, 0.7, what? 0.6, 0.7, okay. Raise your hand if you like 0.6. All right, I guess we're going 0.6. All right. So let's see if they agree with us. Yeah, they went 0.6. Okay, they're saying that this would be, centimeters here. However, we're looking at ruler B here. Now, this is 0 and this is 1. What is every value in between going to be? So this is 0.1, 0.2, 0.3, and so forth, right? So if we have that now, so this one is 3, this is 4, 5, 6. So what would we estimate this one to be now?
0.61.
0.61. That sounds good. Or 0.62. You could, either one would be a good estimate there. They went with 0.62. Okay. Now, on to ruler C. So we have here, now they gave us a mark here. So this is got to be the 0.5 mark in between. So what are all of these now in between going to be? There's 20 markings in between. So each one's worth a what? 0.05. Good. Right? So this would be 0.1. This would be 0.15, and so forth as you're going up, right? Everybody got the little interval there? So, now, what could we estimate this one to be?
65.
So this would be 0.55, 0.60. Wait, yeah. So then we could go and give it one more digit to the measurement, so 0.06 to what? 8. They're saying, well, it's kind of hard to see, but there are individual little lines here. Okay, so basically there's other tick marks in between that we can't see very well. I thought the graphic was better than the one yesterday, but anyways, the 0.6, then the 2, and then we can estimate to the 8 there because there's more markings on the measuring tool. In essence, the measuring tool is going to give you the number of digits you're allowed in your measurement. The better, the more tick marks, the more numbers you're going to have, the more precise and more accurate your measurement will be. Ruler A is allowed to have 1 significant figure. Ruler B is allowed to have 2 significant figures based on the markings on the tool, and then ruler C has the ability to have 3 because it has actually extra little markings in here. Okay? So, what does this mean? Now we have to learn the rules of significant figures so we can apply them to our calculations. Why do we do them? We do them because of measuring tools. Okay? So now we're going to look at this one. This is basically the notes sheet on the front here. Okay? Once again, showing this ruler here. This is 6, so this is 6.1, 6.2, 6.3. And then if you were to estimate that in the middle there, that would be 6.35. So if we use that measuring tool, we were allowed to have 3 significant figures. But you're going to need to look at the numbers and be able to tell how many digits are in it immediately. And every answer from this point on needs to be in the correct number of sig figs. So I will say there's a calculator answer, because that'll give you just the raw answer. Then you have to round it to the correct number of significant digits, okay, when you're doing your calculating. But we are going to follow the Atlantic Pacific rule in order to figure out our number of significant digits. So if here's the U.S. in the middle, over on this side is the Atlantic Ocean. Over on this side would be this Pacific Ocean, the left side. Now, we think Pacific, we think decimal point. Okay, decimal point for Pacific. And then when I think of Atlantic, I think of absent, like no decimal point. So does it have a decimal point or does it not have a decimal point? Because that's going to determine which direction you're going to come from. So if I'm looking at these examples up here, I look at my first example, 0.0012. Does it have a decimal point in it? Yes, it does. So I'm going to start from the left, the Pacific side, over here, this side. Now, this is the rule. You go along the number until you come across the first non-zero digit. When I say non-zero, I mean 1 through 9. Any of those numbers pop up, that's when you start counting. So, the first non-zero there is going to be that 1. Everything after the 1 now counts. Even if there were zeros after the 1, they're going to now become significant. They're holding place values of tick marks on the measuring tool. So this particular example has 2 digits. Okay? If I look at the second example here, there is no decimal point, so I'm going to start from the right. My first non-zero digit is this 1. Now everything after that 1 becomes significant. So this one's going to have how many? 4. Very good. How about this example? Do I start from the right or the left for the 200? No decimal point, absent, start from the right. Now, where's the first non-zero though? It's that 2. So, how many significant digits does it have? Only 1. Okay? And last but not least, this last one, 2.700. How many significant figures in there? Which way do we start? Left or right? Left, Pacific. So we're going to go this way. First non-zero is the 2. Now everything after it counts. How many digits does that one have? That one's going to have 4. Those 2 zeros, because they're beyond the non-zero, now start to count. Okay? Let's look at this first one up here. Does it have a decimal point?
Oh.
No, so which way am I going to start from?
Right.
Right, so I start from the right, go to the first non-zero. How many does that one have?
2.
2. Okay? How about here? Decimal point, start from the left. First non-zero is this 1. How many does that one have? 2. Okay? How about this one? 3.6001. Which way do you start? Does it have a decimal point? So it's left. Go to the left. First non-zero is the 3. Now everything after it counts, that one has 5. Okay? Kind of get it? I do want you to clue in over here to these guys that have the scientific notation. You've seen scientific notation before. What do I do with that? You basically ignore this part. Because expanding the numbers are just going to give you non-significant zeros. So all I really have to do is look at this part. Does it have a decimal point in it? Yes. Start from the left? Yes. So how many digits is that going to have? 2. Right? So that's what you do when you see those ones with the scientific notation. Because now, like I said, we're about to complicate things by multiplying, dividing, and adding and subtracting. Which one would you like to start with? So we'll start with adding and subtracting, but we have to remember place values. Okay, so I'm going to write this number up here. The 1 up there is in the thousands. The 2 is in the hundreds. The 3 is in the tens. The 4 is in the ones place value. 5 is in the tens. The 6 is in the hundredths, right? Then thousands and 10,000s, okay? As you add more decimal places going this direction, you're becoming more precise. More precise, okay? You're adding more precision to that measuring tool that I'm talking about. And this is important when you're adding and subtracting because your answer can only be as good as your least precise measuring tool. So let's look at a first example for adding and subtracting. So here, I'm going to look at this example down here. 2.1647.6171. Before I do anything, I'm just going to go ahead and add it up and get a calculator answer. So let's do that. 2.16 plus 47.6171. We get our calculator answer. Okay? So I want you to write the calculator answer to the right. Then what I want you to do now is figure out how you're going to round it. Let's look at both of our measurements here. This one goes to the hundredths. This one goes to the 10,000s. Which one is not as good in terms of precision? The first one. So guess what? This is the one we're going to round to. So we're going to look at our hundredths place. That's where we're going to round. So, to the right of that 7, is it a 5 or above? It is. So guess what I'm going to do now? Round it up. So your final significant digit answer is 49.78. Right? All right, let's do this subtraction one down here. Let's do, because subtraction and adding do the same rule. Let's look over here. This guy, let's do the subtraction, get our calculator answer. And this I want to see on all of your paper, the calculator answer, the circling, and then the rounded answer. So my calculator answer ends up being this. Okay? Now, let's look at our place values. We have one in the thousands and one in the hundredths. Which one out of those doesn't have the good precision? Or the not as good precision? This one, the hundredths, is not as precise as the thousand, has less tick marks. So I'm going to round to the hundredths again. And because it's a 5 or above, I round it up. So this one's 0.94. Okay? So I want to see all these steps on your paper. Any questions about adding and subtracting? Any questions about adding or subtracting? You're going to have to move on to multiplying and dividing now. Alright, multiplying and dividing does a different set of rules. You actually have to first identify the number of sig figs in each particular measurement. Okay? So, let's look at this first example up here. Go ahead and do the multiplication and write down the calculator answer. 2,909, right? Is that what you got? Okay, now, let's look at our measurements here. How many digits are in this particular measurement that are significant? There's 4. How many are in this one? Good. Decimal points start from the left. This one has 3. So that means my answer can only have 3 significant digits in it. You go with the least number. Now, how do you do the rounding? This is where it gets tricky. You always start from the left. Which digits am I going to keep? Which way do I start and what do I keep? I start from the left. I keep the 2 I keep the 9. Now, the 0 is the third digit. This is the one I have to look for rounding. So I'm going to do 2, 9. Now, do I round the 0 up to a 1 or leave it a 0? This is a 9 to the right here. So I'm going to round it up to a 1. Okay? However, we have a little bit of a problem here. 2,909 is definitely not the same thing as 291. Right? Those aren't even close. So, what I'm going to do here to make my answer seem reasonable, and this is what you do, you're going to have to do what with the 1's position? We add a filler 0, a non-significant filler 0. So, that is the correct rounded answer there. Okay? Let's do a couple more. I'll do a division one. Same rule though, same thing applies. Yes. So let's pick one, anyone. Let's do the 21.2 divided by the 57.14. All right. 0.3692228. That's plenty of digits. All right. Now, how many does this guy have? 3. How many does this one have? 5. How many can my answer have? Only 3. It goes with that one. So I keep the 3, I keep the 6, and now I look to the 9 for rounding. Do I round it up or leave it a 9? I'm going to leave it a 9. So my final answer is 0.369. That is the correct significant digit. All right, let's do a couple more examples before the bell rings. Make sure you're doing this. How about let's go with the 2.8. Let's do this one. 2.8 times 0.55924. This is what I got for the calculator answer. Please check me, though, because sometimes I punch numbers wrong. Is that what you got? Okay. Now let's investigate our measurements. How many does this one have? 2, right? How many does that one have? Start from the left. It's a decimal, so 5. So how many can I have? Only 2. So I start from the left, I keep the 1, I look to the 5 for rounding. Do I round it up or leave it a 5? This one's going to go up, so this is 1.6. Right before you go, I do want to show you one thing on the homework sheet. So, look at the back of the homework sheet, because the homework sheet is just like what we were just doing, but people get confused on this section at the bottom. Sorry, on your paper it says 6, so ignore this. Ignore this part. This is really a 6 on your paper. Okay? All right, so when it says here, so basically round these numbers to the number of significant digits given in the parentheses. Here's your number. And it wants us to only round it to 1 significant digit. So, starting at the left there, that 1. Do I round it up or leave it alone? Round this one up, so that's a 2. So then we have to do what with the rest of the number? Add in those filler zeros. Okay? So for 15 here, it says it wants 2 digits. So let's look. Going across here. The first significant digit is a 7. The second significant digit would be a 7. Do I round up the second 7 or leave it alone? I'm going to round this one up. So this would be 0.078. Okay? That's what it wants you to do on that section. The rest of the homework sheet is just like the note sheet. I want you to finish both. So make sure you do that. And then get your parent-student agreement signed. Okay? Get that signed, please.